This clip is a trigonometry review on how to convert between radians and degrees. We're going to break it up into two problems. We're going to start by converting radians to degrees and then degrees to radians. So after each problem, you will have your own problem to complete and to see how in order to help you with understanding on how to do these conversions. Let's start off by recalling that 180 degrees is equal to pi radians. This is the basis of our conversions. We're going to use this relationship in order to convert from degrees to radians depending on what we want. So if we wanted 1 radian, then I would divide both sides by pi, and I would come out with the relationship that 1 radian is equal to 180 degrees over pi radians. If I wanted my relationships in terms of degrees, I'd start with this relationship and divide both sides by 180 degrees and get that 1 degree is equal to pi radians over 180 degrees. So we're going to start off with A, and we want to convert pi over 12 radians to degrees. So we're going radians to degrees, so I'm going to use this first relationship. So I'm going to take pi over 12, make sure we include the radians, so pi over 12 radians, and we're going to multiply it by 180 degrees over pi radians. It's really important to include our units. So we know we're multiplying these, so these radians cancel out, so the units will cancel out there, and pi also cancel out. So I'm left with 180 degrees divided by 12, which is equal to 15 degrees. Now before you go and do your problem, I want to do a bit of a diagram here to help you visualize what's going on. So if I take my unit circle, I'm really only going to be concerned with the top half right now. So we know the top half, if we have an angle here, it's equal to 180 degrees, which is also equal to pi radians. Now we were given pi over 12 radians. So let's visualize that. So if I was to divide this section, this half circle, into 12 parts, so I'd have 1, 2, 3, 4, 5. So I should have 1, 2, 3, 4, 5, 6 sections. And if I was to do that on this half, then that would give me 12 parts. So pi over 12 would be this angle right in here. That didn't work out so well. So it's this, I'm going to highlight it here in the green. So this green highlighted angle in here is equal to pi over 12 radians. So when I do my conversion into degrees, I should know that I should be getting a small angle. It should be a small number. So if I was to get 45 degrees, then I would know I did something wrong, because visually from this picture, I can see that it's just going to be a small angle. Okay, so at this time I'd like you to try your problem and see what solution you come up with. The answer to your problem is shown in the blue. I'm now going to move on to converting 40 degrees to radians. Okay, so now we're going from degrees to radians, so I'm going to use the second conversion up here. So I'm going to take 40 degrees, make sure you include your units, 40 degrees, and I'm going to multiply it by pi radians over 180 degrees. Okay, so we're multiplying them, so the degrees, these units cancel out. And I get 40 pi radians over 180. Okay, we're not going to go to our calculator and get a decimal. We're going to leave it in the fraction form, but we can reduce it to lowest terms. So 20 divides into both the numerator and the denominator, and I'm left with 2 over 9 pi radians. And we'll leave our answer in that form. Now, let's go to this diagram. We're going to erase it first. So again, we're just going to worry about the top half of the circle. So we know that 180 degrees is equal to pi radian, and we were started out with 40 degrees. So if I was to draw in a 40-degree angle, it'd be just a little less than half. So in here is my 40-degree angle. Okay, so if I was to break this up, it's just going to be a little less than quarters. So I would break it up as well. So it's almost in quarters. So we know that 40 degrees is going to be 1/4, just a little less than 1/4 of 180. So if we went to our calculators and figured out what 2/9 is, 2/9 is a little less than a quarter. 2/9 is equal to 0.222, which is a little less than 2.5. So we know that 180 degrees is equal to pi, so this 40 degrees is just a little less, which is 2/9, a little less than pi. Okay, so now at this time, I would like you to go and try your problem and see what solution you come up with. Your answer is shown in the blue. Remember to leave it as an exact answer and look only to reduce it to lowest terms. So this is how you convert radians to degrees, or from degrees to radians.